All right. So now it's my pleasure to introduce this evening's presenter. Austin Mansfield grew up on the waters of eastern North Carolina, having been raised at an early age along the Outer Banks. His LinkedIn profile mentions, "My passion for weather has been in force since my curiosity arose during the flood of Hurricane Floyd in 1999. I wanted to know anything and everything that had to do with weather." Austin went on to earn his BS in Applied Atmospheric Science from East Carolina University and an MS in Earth Sciences with a concentration in meteorology from the University of North Carolina at Charlotte. He performed research on rainfall patterns in Jamaica and researched the environmental changes in supercell thunderstorms over time. In his own words, "From snowfall to tornadoes and everything in between, I am fascinated by it all," which I'm sure has led him to his current position as meteorologist with the National Weather Service in Sterling, Virginia. He is the local forecast office program leader for the Marine, GIS, and SKYWARN programs. His main interests related to meteorology include tropical marine and severe weather. Austin is also an avid fisherman and sports enthusiast, including professional disc golfing. So Austin, we look forward to hearing from you this evening, and we thank you for also arranging our tour in mid-April. So I'll take myself off of camera so we can focus on Austin, and I'll be monitoring the chat. Austin, so you might break in if anything comes up that you need to know.
Okay. All right. Great. Thank you so much for that introduction. Hello, everyone. Go ahead and share my screen here. Can everyone see the screen correctly? Got the update on marine forecasting?
Yeah.
Yep. All right.
Yes, we can see.
Great. All right. So, so we're going to be talking a little bit about marine forecasting, modeling. I'm going to kind of run through some of our marine products. So, what we do in terms of forecasting for the marine areas. Try to go a little bit more in depth on, what it takes as a meteorologist to develop a marine forecast. So I'll run you through some of the modeling that we go through and some of the different types of observations that, we account for when we actually go to make the forecast, and when do we need to make a decision on, if we need to update the forecast or we need to update, if we have a warning or an advisory out. So we're going to have a lot to cover tonight. So if you guys have any questions, certainly put them in the chat. I'm always a big fan of interactive presentations where a little bit of give and go in terms of if you guys have questions or anything like that. So looking forward to hearing some feedback from you guys. Okay, so again, my name is Austin Mansfield with the National Weather Service here in Sterling, Virginia. I've been here since March of 2020. As Cheryl said, that I'm currently the Marine GIS and SKYWARN program leader at our office. Other programs I've led include social media, tours, and outreach. I love talking to people and being able to interact with the public and our partners. So I certainly, I love actually going out into the field and interacting and educating is another big part. I also work with ASOS operations, so I go out and assess some of our equipment that's within the Weather Service and that we maintain. And then I'm also have been a part of the backup program, which would be whenever we have an office that's one of our neighboring offices, specifically the State College, Pennsylvania, and the Mount Holly, New Jersey offices. If they were to have something go astray or they need to be backed up, then we would step in and present the forecast for them. I think we talked a little bit about the education. So my thesis was on the temporal evolution of tornadic and non-tornadic supercell thunderstorms. So I really looked at the cycle of these types of thunderstorms over time using radiosonde data from weather balloons that were released during the research period. Again, I am a professional disc golfer and also an avid fisherman, both freshwater and saltwater. So in terms of the agenda for today, we're going to be talking a little bit about the National Weather Service mission and what that is. We'll briefly touch base on our local marine jurisdictions, and then we'll get into the meat of the presentation about talking about our products and what we do in the Weather Service when it pertains to marine forecasting. I'll talk about some of the dissemination methods of our products and how we were able to get the word out and get this information to you guys to be able to understand your needs that you have when it comes to marine forecasting. We'll talk about forecasting techniques and tools that I use. So I'll kind of walk you through the steps that I would take when I go to make a marine forecast. And then I wanted to, briefly touch base about thunderstorm interactions with the Chesapeake Bay, and kind of give you a little bit more in-depth analysis on, thunderstorms in general and how they interact with the Chesapeake Bay, and what are some of the implications with the Chesapeake Bay and just bodies of water in general. And then I want to become an infomercial for the last few minutes of the presentation and talk about our SKYWARN program, as well as hoping that you guys would be able to come Marine Weather Ready Nation ambassadors for our office. So the National Weather Service mission, this is kind of the big part here, is that we provide weather, water, and climate data forecasts and warnings for the protection of life and property and enhancement of the national economy. But simply put, we're here to protect life and property. So my job and my main mission within the Weather Service is to protect life and property, and we do that in a number of different ways, whether it be giving warnings, watches, advisories, communicating with the public, letting our emergency managers know of inclement weather that's coming, educating the public about the awareness of a certain type of natural disaster. So a lot of different hats that I wear when it comes to the Weather Service, but it all is going to boil down to protecting life and property. So here's our marine area of responsibility. So we cover a pretty wide area of the Chesapeake Bay, and then we also serve the entire tidal Potomac River as well. So each one of these different colors represents our forecast zones. So when we go to issue a product such as a small craft advisory, we're not going to issue it just for a small little inlet. We're going to want to issue it for a larger area, because we know that there's probably implications for a small craft advisory. We would maybe expect winds to be in excess of 18 knots at that point, but they probably would be more widespread across a certain area. So we've developed these marine zones to account for those types of situations and how they interact with the Chesapeake Bay and the tidal Potomac. So you'll see these different zones on our forecast products, and I'll show you guys that in just a little bit. This is available on our marine page, so it's an interactive link, so we can actually go in and click and select any of these zones that you would like to view. All right, so we're going to go into the meat of the text products that we issue that pertain to marine forecasting. So I'm sure a lot of you are aware of our coastal waters forecast. So a CWF, which is issued a minimum of 8 times a day or every 3 hours. And there will be times where we will issue them even more than that if we need to make an update to the forecast. So we certainly can have amendments during that time. Each CWF goes out 5 days, with each period covering about 12 hours. We don't want to go past that, because that's the period in which our marine products go out. So we won't issue anything like a gale watch or anything like that past 5 days, because there's such a variation in forecasting. Once we get further out past that 5 to 7 day period, it really starts to get a little bit trickier in terms of understanding the capabilities of modeling and forecasting at that point. So that's why we cover at our office days 1 through 7 for the forecast period. But the CWF, it's used by small pleasure boaters to large commercial transport ships. So anybody that uses the waters can certainly pertain to the coastal waters forecast. The elements of the CWF, the synopsis is really short and concise. We just want to get the word across of what to expect based off of our forecast grids that we have in our forecast database. We also will show the headlines of longer duration hazards, such as our advisories, watches, warnings. The wind will be from 8 different compass points, and that's going to be in knots. Waves, we look at wave heights in feet, and then weather. So any type of weather that we're expecting that comes from our forecast database is going to show up in there, whether it be thunderstorms, precipitation, fog, especially, the significant reduced visibility. Here's an example of what our product looks like when it comes to the CWF. It really breaks down, from the synopsis and goes down towards bringing in what to expect during that period of time, whether it be from days 1 through 5, and then gives the breakdown, which I think listening to a lot of our marine partners, that is really useful for our partners to have, is that the different quantitative data that's located at the bottom of your screen here, showing each day the wind direction, the wind speeds, and the gusts expected, as well as the wave heights. All right, so in terms of marine advisories and warnings, we have we'll start off with the watches, and then we'll kind of build our way up to when we start to see warnings and advisories. So with the gale watch, we see that with sustained winds or frequent gusts of 34 to 47 knots, beginning period 4 through day 5. And we want to make sure that's not associated with a tropical cyclone, because we have another product for that during those times. A storm watch, we start to ramp up our forecast for winds, whether it be from 48 to 63 knots. And then we go to hurricane force, anything greater than 64 knots. So the main takeaways here is, in terms of the wind speeds, certainly we have a range for those. And then we also will start these from the period 4, which will be from, we look at, when we talk about periods, we talk about today, tonight, tomorrow, tomorrow night. So a tomorrow night period through day 5 is when we would start to see these types of watches be held. So the next part, this is when we start to see the conditions are going to be more favorable for this to happen, and we're getting closer to that period. So then we'll start issuing, a lot more of these products. So the small craft advisory, I'm sure most of you probably are aware of this. This is our most used forecast and most used hazard that we issue every single year. We issue thousands of small craft advisories, and that is for sustained winds or frequent gusts of 18 to 33 knots. And the frequent refers to lasting greater than 2 hours. So you're going to hear a lot about 2 hours in this presentation, and that's kind of like the threshold that we look at when it comes to issuing a certain product versus the other. And then seas of 4 feet or greater, we would also issue them for small craft advisories. Gale warning and storm warning, it really goes from that watch to warning phase when we start to see the conditions more favorable and we're getting closer to that time frame. So we certainly ramp up the winds in that case from 34 to 47 knots, and then 48 to 63 knots. And then we have the hurricane force wind warning, which of course will be in excess of 64 knots. We do have a new product that as of just last week, I believe, is now in effect for our area. So that would be the Marine Dense Fog Advisory. So that's going to be for dense fog over marine zones lasting 2 hours or more and resulting in visibility 1 nautical mile or less. So I know that the Wakefield, Virginia office and the Mount Holly, New Jersey forecast offices both have already used this product and have been using this product, but we are now joining in on this product as well, so that we will have marine dense fog advisories in effect from now on. This is actually pretty rare across the Chesapeake Bay in terms of getting to, a visibility of 1 nautical mile or less for a larger area. We'll certainly see it in more micro areas, but in terms of frequency throughout the year, probably 4 to 5 times a year is when we would see this happen. I know we've seen it at least once in the last few months, but that's it's pretty rare for us to be able to see it last 2 hours or more for a larger period, a larger area of time. So when we go to issue these types of products with whether it be the dense fog advisory or a small craft advisory, any of these headlines that I've been talking about here recently, we issue them from the Marine Weather Message. So the MWW is where the product itself comes from, and the headline product for our marine wind headlines. The warnings issued for the first 3 forecast periods, and then the watches, of course, from that period 4 through day 5. It includes the CWF synopsis, which highlights the potential for marine headlines beyond the first 3 forecast periods, and that's unless a watch is issued. So unless a product is issued during that time, the CWF will highlight that potential. But once a product has been issued, it's no longer included in that because we have another product that makes it aware of that situation. It also plays on the NOAA Weather Radio and VHF. And these are the different sections here. So we have that what, where, when, and impacts. So we include the wind directions, wind speeds, and gusts. We also want to include the location. So that is solely based off of our forecast zones. So it'll take what forecast zones are included, and it has it here in the blue section at the top, and it also includes it down in the where section. And then the wind, and then impacts. So any type of major impacts that it would have. So for example, this is a small craft advisory, just saying it would be hazardous to small craft. We don't have like a threshold or anything in particular of a guideline for what is considered a small craft. So we don't want to make that decision. We know that the people that use their boats and use their sailboats and any type of equipment on the Chesapeake are aware of what their vessel can handle during those situations. But when we actually implicate these impacts, we say conditions will be hazardous to small craft. Another product we have, the Marine Weather Statement. So that's issued to advise of weather phenomena that could impact boaters. Gusts, for example, gusts 25 to 30 knots, but it also is of short duration, so 2 hours or less. So this is where we're starting to get to that 2 hour period where less than 2 hours is when we start to see the marine weather statements be used. And then once we get past 2 hours, we start thinking about gale watches and warnings and small craft advisories, stuff like that. Some other examples would be gusty showers or thunderstorms with winds less than 34 knots. So we just have a gusty thunderstorm or a gusty line of showers coming through, and we're expecting the winds to remain less than 34 knots. We'll issue an MWS for that. Wind gusts near gale force if a small craft is in effect, but the duration isn't long enough to necessitate a gale warning or an SMW. I'll also issue it if it's very infrequent in terms of the gale force gusts at that point. If we already have a small craft out, especially if we're just seeing 1 to 2 observations during that time frame of less than of greater amounts, then we'll certainly have an MWS out for that. Fog, precipitation, small hail, lightning. So when it comes to fog, we have another way of doing it with dense fog now. So we talked about having the marine dense fog advisory. It goes from the 2 hour, greater than 2 hours, and 1 nautical mile or less visibility, whereas the marine weather statement will issue it for fog that could be greater than 1 nautical mile visibility, and then also we could have dense fog that is for 2 hours or less is when we would issue a marine weather statement for. This is an example of a marine weather statement here. The left side just includes a radar graphic from Radar Scope. But I'll quickly talk about the sections here. So first we'll have a quick tagline that just shows what we're expecting or what is occurring. So strong thunderstorms approaching the waters. We could have something like a gust front approaching the waters, or that it's affecting the waters as well, as what we could put in the top line. Areas affected. So we'll put the actual title and Chesapeake Bay zones that we talked about. And then we'll give a brief synopsis of what is expected, what's happened at that point. So when it comes to marine weather statement, we're doing the same thing that I would do for if I'm going to issue a severe thunderstorm warning or a tornado warning. I'm going through the same process with I'm the warning operator at that point. So that's my responsibility is to serve the same purpose when it comes to marine areas as well. And so we have these products that very much mirror what these other products would look like. And then we also have locations that would be impacted. So we would include like places that are closer to the waters in those areas as well. And then we have a bunch of precautionary and preparedness action statements that are located at the bottom of the statement as well. Let's see, quickly look at the chat here, see if there's any. So, Bill, I think we talked about the small craft. How we don't really have a set guideline or threshold on what we consider a small craft, because we don't want to open up that can of worms and let people not know and maybe think that their vessel could be susceptible to small craft advisory conditions versus gale force winds. All right, so now we're going to switch gears to our convective hazards. So these hazards certainly do affect the waters. So we certainly like to look at these products as well for the water. So whenever I talk about convection, the rest of the presentation, I'm referring to thunderstorms. So we'll first talk about the Storm Prediction Center located in Norman, Oklahoma. So we interact with these national centers within the Weather Service, and we want to be able to interact with them because I wear so many different hats as a meteorologist at the Weather Service, and I have to focus on a lot of different aspects of meteorology and focus on a large area. I cover 28,000 square miles of area for my forecast. So we have these national centers that focus on one single thing or one group of things that are pertinent to the forecast itself. And so, for example, the Storm Prediction Center, they help us in understanding the potential for severe thunderstorms, tornadoes, things like that pertain to convection and thunderstorms. So they release convective outlooks. The day one convective outlook is issued 4 times daily. The day 2 and 3 outlooks are issued 2 times a day. And so they include the watches that pertain to tornadoes and severe thunderstorms. This is just an example of what their outlooks look like. So they'll usually take the strongest area will be included in the the middle of the contour, and then they'll start to expand a little bit as you go further out. So this is an example where we had an enhanced risk, which would be a category 3 in the categorical outlook. It goes all the way up to 5 of high. Fun fact, we have never had a high in our forecast area. I hope we don't. That certainly would be a very, very, very busy day for me. But it certainly is possible. But they're most likely to occur across the Deep South and the Great Plains area. Here's an example of our severe thunderstorm watch that we've had issued. So notice it does include the waters. So when we go to do these products, the SPC may not think about the waters at that point, and that is our responsibility to make sure that when they go to process what the watch is and what we want out of the watch, we're always going to tell them if we think it's gonna affect the waters, then we're certainly going to include the marine zones in there. All right, here's another product that we will certainly use, and we use a lot, especially during convective season. So this is a special marine warning. It's issued for potentially hazardous overwater weather conditions of short duration, so 2 hours or less, and producing wind speeds or gusts 34 knots or greater, and not covered by existing longer fuse products. So this is kind of that gray area where we have something that's affecting the waters, but it's going to be less than 2 hours, but we're getting like gale force winds with it. And so we have the special marine warning in order to account for something like that. It also works with water spouts and hail of three-quarter inch diameter hail or greater. It also, we started in 2017 that if a gale watch or gale warning is in effect, we can issue an SMW for short duration with wind gusts 48 knots or greater. So once we get the storm force winds, then that's when we can issue a gale warning for. The other instance will be if the gale will have a sudden onset, so a strong shift in wind direction, or a strong onset of the winds to just go ramp up. We'll certainly issue an SMW for that approaching gust front as well, because we want to make sure that our marine users are aware of these rapidly changing environment So we'll certainly issue a SMW for those as well. Here's an example of a special marine warning. So you can see it's very similar to a lot of our products, especially the products that we'll issue during an event. We'll have very similar text products in terms of their structure. So we talked about the source, the hazard, and the impact here. So the hazard, we will say that wind gusts 34 knots or greater, small hail. If we have frequent lightning, we'll also put that in there. A source will put radar indicated. Most of the time we'll put that. There could be instances like if we got a report from the Coast Guard or one of our spotters along the waters and they say that there's a water spout, we'll certainly put that in the source and say, train spotter reported a water spout at this location. And then we also put impacts as well. So just talking about the potential for, what could happen if they are affected during that time period. And then I know that a lot of marine users also love seeing the lat long for these areas. That certainly is helpful for them. And then it also includes the storm motion here. So this is saying that the storm is moving from 264 degrees at 40 knots. And then down at the bottom, we have our hail sizes and our winds to try to simplify it a little bit. Quickly look at the chat here. Read the forecast discussions for the forecast. Absolutely, yeah. I take
you had a couple people comment on that forecasters discussion.
Yeah, absolutely. Yeah, I don't think I have it in the presentation. I'll certainly touch base about that here shortly. When it comes to the forecasters discussion, we take a lot of pride in writing these discussions because it's kind of my time to really nerd out and be able to provide as much information, kind of have like diarrhea of the mouth at that point, and being able to really go in depth about what we're seeing, because I can't really speak a lot of words into my forecast, but when I do my discussion, I can write as much as I want to for as long as I want to with writing these discussions. So it's certainly something that we're very passionate about, being able to have that time to talk about the implications of what's occurring, the uncertainty, because we can't put uncertainty in most products. I think we're getting into like a probabilistic forecasting type of period when it comes to snowfall, and I think that eventually it'll get to that period for a lot of forecasting. But overall, we don't have many times where we can address uncertainty strictly in the forecast. So we have forecast discussions to be able to show that as well, and provide what we're seeing, what we're thinking is happening, and try to give a little bit of science background, get a little nerdy when it comes to our forecasts. So yeah, glad everyone's enjoying our forecast discussions. So now we'll talk about tropical hazards. So we have our tropical watches, warnings that are issued by and in conjunction with the National Hurricane Center down in Miami, Florida. So for tropical storm, sustained winds 34 to 63 knots, and then hurricane force winds and hurricane watches and warnings are for greater than 64 knots. And they go, obviously you've heard, they go way up, all the way up to category 5. I've had questions here recently about, I think there's been like some chatter where people have asked about, is there going to be a category 6 added to it? I don't think that's going to be possible and very sustainable within, our world. So I don't think that we have anything to worry about in terms of that. It's really hard to get to a category 5 in general. So as of right now, I don't have any expectations for that to change. And here's an example of what their outlooks look like when they go to make these forecasts in terms of the storm itself. And I want to kind of talk about how this needs to be interpreted. And I'm sure most of you are fully aware of it, but I always like to show this whenever I'm giving a presentation like this, to show the graphic itself. We have what most people would call the cone of silence, or cone of uncertainty, and what it does is really just showing where do they expect the center of low pressure for this tropical system to be, and that's all it is. So it's not showing the implications that could happen beyond that area, because when we talk about social science, a lot of the public looks at this graphic and just says, okay, I live in Charlotte. It doesn't look like I'm going to be hit by this hurricane or I'm going to be affected by this tropical storm. When in reality, this storm field could be hundreds of miles wide and could certainly affect you and could certainly provide a lot of destruction and damage. So this is solely based off of the center of low pressure track and where the potential for that center of pressure, low pressure, to be during that period of time. A new addition that they're making to these graphics for this coming year is that they're going to go inland on showing the watches and warnings. So, for example, this graphic, you would have seen most of the state of Florida, aside from probably the Panhandle, all lit up in red or blue with the hurricane watches or hurricane warnings and tropical storm warnings. Any questions about?
You have one about how to someone become a spotter. I don't know if you have that later in your
Yeah, John, thanks for the
presentation,
question.
but one of our members already put in the chat earlier that he is a spotter and even gave his number. So you do have people interested in that. So whenever you want to talk about that.
Yeah, absolutely. We're gonna. I'll have some slides here at the end. So just sit back, relax, and we'll get to that here in just a little bit. Certainly talk about becoming a spotter, the training that's involved. We'll go over all that.
Okay.
All right. So now we're going to talk about marine hazard dissemination. So how do we convey the message today, and what does it take to convey that message to the public, and how do we get it across? So the first one I'll talk about is NOAA weather radio. I really hope that most of you have a NOAA weather radio. If you don't, I strongly suggest getting one. So you're going to get our forecasts and our warnings within a minute of issuance if you have a NOAA weather radio. So as soon as my finger hits the click on the mouse, it will tone on the NOAA weather radio within a minute of issuance. And it'll also show all of our, it'll voice out all of our marine products that are broadcasted on the NOAA weather radio. Website-wise, we have our weather.gov website, /Baltimore, /Washington, or /LWX, Lima Whiskey X-ray. We have some colorful maps on the website where you can click to see the text. You can also visit mobile.weather.gov if you're using a mobile device. We have the recorded forecast, which just shows this. It conveys the CWF only that you can also visit. And then we have third-party retransmits, such as the Coast Guard, as well as the FEMA app. Another one that we will also convey would be social media. So we've certainly seen social media become very wide mainstream at this point over the last 10 to 15 years. So we certainly convey that to any type of gale warning or heightened situation that we would have over the waters or affecting the waters. It will go to social media. When we go to issue special marine warnings, they'll actually automatically go to Twitter and Facebook. So we have a way to auto-generate these products based off of as soon as I click the button to issue the product, it will go straight to social media so that people are aware that way as well. So we want to you're kind of getting the idea that we want to get the message out as many ways as possible, and do it in a very timely manner. Because a lot of these products are going to be very intense situations that could affect a lot of lives very quickly. So mariners are our top NOAA weather radio users. So there are 7 transmitters that cover our marine area. And they will have, again, they'll tone alerts for special marine warnings. They'll also go over for any types of other products that we have, whether it be the coastal water forecast, any marine wind headlines, as well as observations that are occurring within that area as well. We'll briefly talk about our website. So this is the website for the National Weather Service in Baltimore, Washington. So the centerpiece here in the middle, I call that our WAWA map. So our watches, warnings, and advisories map. And so what this does is it shows any of our watches, warnings, and advisories within our area, as well as other areas along our neighboring offices. So if they have a product out it will also show up in here, just so that there's no gray area between office to office if there's a product that was issued. So that'll show up there. We also have a number of different graphics just below it. So we have our satellite, local radar. This weather obs map viewer also changes to our weather story. So that's kind of like a 1,000-foot view of what to expect over the next 1 to 3 days is what we'll put in that. Oops. If you in terms of the marine forecast, you can go up here to this these blue text here that shows forecast and go to our marine section. And you can actually visit our marine page that way. You can also go down to marine forecast here, and it will generate the marine page, which the center of the marine page just shows our graphic that I showed at the beginning that shows all of our marine zones that you can go to click on. And then we also have text products that are at the bottom that you can click on as well. I'm actually in the process of gathering a team to redesign our marine page. So if any of you guys are interested, please feel free to reach out to me after this, and we can certainly discuss trying to figure out. I'm very interested in knowing what our users are most passionate about when it comes to marine forecasts and what they need and what's going to best fit them in terms of the forecast. So certainly have been listening to a lot of people discuss that over the last couple of months. So if you are interested in do that, please feel free to reach out to me regarding that. So here we have our tides forecast. They can be visited at water.weather.gov and tidesandcurrents.noaa.gov. This is just an example of what our forecast looks like in terms of our tidal locations. So we have different levels of flooding that are involved. We'll first start with action stage. We go up to minor flood stage, moderate, and then major. Action stage is kind of like we're starting to see water increase, but we haven't gotten to flooding implications at that point. But then the rest of the stages do implicate flooding in certain areas, and we've developed these thresholds as we've worked with emergency managers within the community to figure out where these thresholds best fit for the impacts that are involved with it. So the observations are the blue line, and then the forecast is that maroon line. And you can visit that if you go to that same text area here just above the map and go down to tides, coastal levels, and flooding. And when you go to it, it'll come up with this map here, and you can select any location of our forecast points that we serve in terms of tidal locations. So we only, our office solely will base it off of observations along the western part of the Chesapeake Bay. The eastern shore is hosted by the National Weather Service in Wakefield and the National Weather Service in Mount Holly, New Jersey. But we're always in constant communication with them to update our forecasts and make sure that we are congruent with what they're having as well. We have buoys within the Chesapeake Bay and the Potomac. So we have the Chesapeake Bay Interpretive Buoy System, CBIBS, launched in 2007 to 2010. They are the only wave sensors on the bay. You can access that data at buoybay.noaa.gov. And then dial a bay you can call, and you just need to know the site ID to be able to get that information. And then they also have the Smart Buoys app as well. All right, so that was a little bit about some of our forecasts, what we have on our website, and what we have going forward. Now we're going to kind of switch gears into the forecasting of the Weather Service and what we do in terms of making. Yes, ma'am.
There was someone that did post, how does your information get out into web apps like windy.com? You might be hitting on that later. I just wanted you to know that was in there.
Yeah, thank you. Yeah, so when it comes to apps like that, all of our products and our information is public information. It's a federal organization, so all of our information in terms of our data that we give out in terms of forecasts or anything like that, it is public information. So these apps and these groups are taking it and just making, coding it to where they can, produce it on their application or their, using their apps as well. Let's see, Doug here. Many mariners use commercial apps for weather radar depiction. We'll speak to radar latency, presentation delay, and how that can be compounded by commercial app users and such data. Yeah, there's certainly going to be a delay when it comes to processing it from like our radar and then into their radar. So I can't really speak on their like other apps and how they do their programming and are able to ingest our data as quickly as they can. But in terms of when we get our information, I'll be able to get the radar information within a minute of it occurring. That's usually about the fastest that we would see, or within the minute, really, with some of our new upgraded equipment that we have within our radar. But in terms of going from app to app, it really differs and it really changes based off of their capabilities within their app. I can't like say what app is the best in terms of weather radar information, but there certainly are a lot, and I strongly suggest going through and just getting a feel for which ones are really useful for you in terms of your needs and what you have. The main one that we use within the Weather Service, and a lot of people within the Weather Service, because we have a partnership with them, is RadarScope. And so we use RadarScope in some of our social media, as well as just be able to visualize what's happening within our area. Let's see. John said, "How can we obtain the weather station coverage map you've shown?" To obtain
And that might be answered by Dave right beneath it, I think.
Let's see. Yeah, I believe.
Is that the right one?
Let's see here. Yeah, for NOAA weather radios, yes. Yep, you can go in and click that and look at it.
The issue and the question I was asking was, you shown it in a format that's different than what's on that website. The way you showed it allowed a mariner to know what they would expect the most useful or highest signal strength associated with individual channels. What's displayed online is location of the transmitters, their FCC transmit numbers, which don't relate to WX1, 2, 3, 4. But that map you had did, and it seemed extremely useful to, as you're traveling down the bay, what weather station would be the best to listen to.
Yeah, absolutely. I can, I'll make a quick note of that, and we can actually see if we can get that included on our Marine page. That's good information. So thank you so much for that, John. All right. Yeah, thank you for that, John. Let's go back towards guys here. All right, so now we're going to start talking a little bit about our forecasting techniques and what we do in terms of making the forecasts. So I'll briefly touch base on a couple of different products that we use at the office and what some of the components are. I won't go too far in depth with them, but I'll definitely give you the overview of what each product would use in terms of making the products and looking at these products to make the forecast. So the first one I'll quickly show is here is BuffKit. So this takes sounding data. So data from various models that we have. It's probably kind of hard to look at that top left-hand corner with the green lettering. But those show a number of different models that we have. So the one that's selecting right now is the NAM. We also have like the RAP, the GFS, the SRF, the HER, the ARW, the FV3, and the NAM Nest. I think are all the ones that are located on this. And then we have forecast points in this area. So we look at, right now we're looking at NHK. We'll also have like Annapolis and then further north up towards like Martin State and BWI to get that information as well. So what it does is it takes, once we got all this information from the models and they've ingested into the system, we can now look at the data from a different point of view rather than just seeing, where is it going to rain at in a certain area, because these models give so much more information rather than just showing, when is it going to rain and how much is it going to rain. So this is an example of what we're talking about here. This is showing a sounding, like a derived sounding from the green line representing dew point and then the red line representing temperature. And so what it's doing here at this point is showing, the variations in the temperature, the dew point, and then the wind speed. So that graphic, or the area along the right-hand side, is actually the wind speeds that we see here. So down at the bottom, we're looking at anywhere from 15 to 20 knots. And there's a very faint gray line down at the bottom. That's a really important line that I look at when I look at this app. Is we go to look at this in a way to see how well are the winds going to mix down, because we can see on a model and it can show that there's really strong winds and there's potential for really strong winds. But the thing I always have to have in the back of my mind is, are these winds going to mix down to the surface? Are we going to have winds that are susceptible to make it all the way down to the surface for us to be able to produce these strong winds? And so this is looking at the mixing level. So is there enough mixing involved with being able to produce these winds? So are we getting this rapid mixing coming from this above the surface down towards the surface, and can we produce these stronger winds from there? So like this is just showing, just off the surface, you got 25 to 30 knots of wind, but it's a matter of how much are we going to mix down to get this wind. So this is an example of what the sounding looks like. This is also a way. So if I toggle back here, there's a little tiny knob on the top right hand side that says overview. And what we look at here when we look at the overview is just another way to visualize this data. And so from this graphic here, we're looking at wind speeds, the mean mixing ratio. So that ratio I talked about, where it looks at, where the most mixing is occurring and what winds are associated in that mixing layer, as well as shear involved in this graphic here. So what I'm looking at when I look at this graphic here is when I start to see some of these brighter lines here, so these yellows, these greens and blues, when they start to get closer to the bottom of the graphic, that tells me that these winds are getting closer to making it to the surface. And so when I start to see these colors start to get closer to the surface, that tells me that there's ample mixing. There's ample availability of these winds to make it further down and punch down towards the surface and towards the water. So that tells me that there is a chance for these to get closer down to the surface and produce these types of winds. So this is just an example of one of the tools that we use when we look at these types of situations. I'm going to look at a lot of different models with this. I'm not just going to take the NAM here and just run with it because I see that there's 20 to 25 knots possible just off the surface. So a lot of other implications that we have to look at, not only just in the modeling but also observations, previous ways that we've been able to interpret the same type of situation that or event that we can use to convey that same forecast, that same type of method. Another way we look at it here, we have our convective allowing models. So this is we use some of this in that last graphic in BuffKit here in that top left hand corner, but with convective allowing models, these are your shorter range models. So they're focusing on a shorter time frame, whereas you have like the GFS model, the longer term models that focus on 360 hours out. Whereas these models get a little more in depth and they focus on the implications that are happening in a 0 to 48 hour time frame for the most part. So I'll give a couple examples here with the NAM 3 kilometers. So 3 kilometer NAM or NAM nest is an example. And what I'm looking at here is our 500 millibar heights. So this could be something where we're looking at the potential for how cold the atmosphere is, way up in the atmosphere, and if it's been able to drag down, much cooler air mass from it. So if I'm looking at, for example, during the wintertime, there's a 540 line here, and that's been researched a lot to show that is, an ample time for sub-freezing temperatures. And so I can look at that 540 line and see that it's way up there, in the Great Lakes region, and to know that, the implications of freezing temperatures is probably pretty low in terms of probabilities. And I can also look at winds as well, whether it just be at the surface or further up off the surface. So here on that right-hand graphic is our 850 heights, so 850 millibar heights, and we can look at the if we're seeing winds building in from a certain system coming from either the west, east, south, anywhere, to show where it's coming from, where is it strongest at. And what do we expect, across our area? Because it certainly is modeling out, what to expect over, that certain period of time. The HER, for example, it updates every hour during the day, so we get constant information, constant new updates for these types of models. Long range ensemble probabilities. So we have some of these models have ensembles, so they have a plethora of different model runs that are running at the same time and going through a lot of different phases. You're plugging in, when they do the modeling and the coding, they plug in different variations of it to account for certain situations. So a lot of like really complex coding and modeling outputs go into these models, and then we produce ensembles that have, if we were to look at this a different way, I could go in and look, and there be individual members of this model, so of the European model, and it would show what the probabilities are based off of each single run that it has within that variation. So what you're seeing now is the average or the normal for this time frame. So right now this is showing the probability of wind speeds of 10 meters off the surface of greater than 34 knots, and what are the probabilities of it. So we don't see much in along our waters, but further out towards the open waters, we start to see the better probabilities of 50 to 60% chance of greater than 34 knots. And this is actually for, I think I looked at it a few days ago. Yeah, so it was initialized the 21st, the evening of the 20th, and then it's valid for around midnight on Thursday. So this is looking at what the potential is for those wind speeds. So we can look at that to get an idea of what we're expecting during that time frame. So this is a new thing in terms of the revancing of this system, the nearshore wave prediction system. So this shows a lot of really good information and good data that we can go in and look at the different types of components that probably are really pertinent for you guys. So we have wave heights, we have peak period, wave direction, in degrees, and then wind speeds that are associated with it. And it takes our modeling data into the system, as well as other data that's involved within the Weather Service and within NOAA. It's been around for a little while, but it's certainly has gone through a major shift in how it's being processed. So the National Water Center, which is going to be becoming very much more pertinent to the forecast system and the forecast methodology when it comes to forecasting tides as well as flooding in general, and they've really taken a different approach, and you're going to see this become very, very common with forecasting rather than what we have for like the AHAPS page, the Advanced Hydrological Processes page, that shows the forecast for the inland flooding as well as tidal flooding and tidal locations as well that we have like along the Chesapeake and the tidal Potomac. Here we have our observational systems. So this is we're going to kind of touch base on the observations that are involved with forecasting and what we kind of look at in terms of the forecast and how we can visualize it if we need to make a change to the forecast, if we need to visualize a different aspect of forecasting. And so here we have CBOF, so the Chesapeake Bay Operational Forecast System. So we can click on that and look at any of these forecasts for any of these sites and look at how the forecast is changing. You can actually look at this website yourself. So this isn't like a website that you're restricted from. So you can certainly visit that to look up our observations that are happening. I've talked a lot with marine users, and we've kind of tried to bring up a few examples of other applications that within NOAA that people use. So we have NowCoast, which will bring in all of our products that we have, not just along the coast, but even further inland. It also brings in our radar graphics from any radar within our area. You can overlay a lot of different things, so it's really useful to be able to visualize what's occurring. You can zoom in on the product and look at your specific marine zone or area that you're being affected by. So a lot of good information for that as well. Here's Tempest One. So we use this a lot within our office. This is to look at the wind speeds and wind gusts that are evolving across areas along the tidal Potomac and the Chesapeake. And we look at this to give us information on validation on is our forecast doing well. B, if we start to see stronger gusts compared to what our forecast is, I need to make adjustments to the forecast. I need to potentially issue products like a marine weather statement, an SMW, anything like that. And I can use information from further northwest or further west of the waters to get an idea. So if I start to see, for example, one caveat that we always use is when we have a strong line of storms and they may be approaching Martinsburg or Loudoun County, that once we see gusts 30 to 40 knots, at that point I'm probably going to be issuing a special marine warning for the northern tidal Potomac and the middle Chesapeake Bay, because the probabilities of it affecting the waters in the sense of greater than 34 knots is certainly high across those areas at that point. So that's one thing we always have in the back of our minds when, especially during convective season. All right. So we're also going to switch gears here to, I want to talk about severe weather in the Chesapeake Bay, but I also want to go a little bit in depth on thunderstorms and the ingredients that are involved with thunderstorms and how that the different implications of thunderstorms and what they experience as they're getting closer to the Chesapeake, or if they're already over the Chesapeake and what's kind of affecting them. So the first one in terms of ingredients, and we'll talk about three main ingredients here. The first one being moisture. So your moisture sources for our area would be the Atlantic, the Gulf of Mexico, and then the Bay alone. So you may think that's kind of strange that like the Bay would really affect it. It's not really that big of a body of water compared to the others, but it certainly does, and we'll kind of talk about why that happens. We have lift. So for lift, you need a mechanism or a boundary for convergence, and cold fronts are a great source of lift. This is kind of a graphic that shows when we talk about lift and what a cold front looks like. So you have this cooler air is forcing this the air ahead of it to rise up and condense as it moves up, and that's when you start to see precipitation start to form. So you have that convergence of wind along the cold front in this image and producing the cloud or the condensation as it's affected by that boundary. So a couple of examples of lift. We talked about the cold front. We have a warm front. So it's pretty much the opposite with warm air moving into a colder environment. Stationary front, so a stalled front that just kind of sags. A lot of times when we see a stationary front, that kind of will bring a lot of precipitation over an extended period of time. We have orographic, which affects from hills and mountains, and then thunderstorm outflow. which is usually cold air blowing out of a thunderstorm. Now, I highlighted one in particular, and that would be the bay breeze. So this is moist, cool air moving inland, and this is from the Chesapeake Bay itself. And a lot of times we'll see this in like the mornings and the evenings, to where we start to see this cooler air coming from the bay and sweeping in further inland. And these types of situations can certainly affect how thunderstorms interact at that point, and how they're affected by the bay breeze can certainly cause chaotic situations where you could have a storm really fire up as it hits the bay breeze, or the overall structure of the front or the thunderstorm alone can really expand or be affected, negatively, where it weakens. But a lot of times the bay breeze is something I'm always looking at, especially during the summertime. If we have thunderstorms happening where we may think that it's getting closer, if someone's looking at a radar, they could think oh, okay, it's starting to dissipate across this area closer to the bay, but then I start to see the bay breeze forming, and I can see it. You can see it on radar, because you can see the wind associated with the clouds that are associated with it move from over the waters onto land, and that really that makes me know that it's probably not over yet. We're probably going to start seeing more storms form, or the storms that are already happening become even more complex. Another ingredient would be instability. I got a lot of information on this slide, but the main thing we'll talk about here is an air mass is considered unstable if a parcel of air continues to rise when giving a nudge upward. So, like a cold front would be an example of giving that nudge. So, when we talk about the overall structure of what we mean by instability, is you have that unstable air mass, the more moist air near the surface, while you have that cold, dry air as aloft. So you're basically just doing this. You're mixing. A good example I always like to give is, let's say you have a pot of water and you're trying to boil that pot of water. If you had a clear pot that you can look at and you can see the water as it's beginning to boil, you'll see that the water is constantly rotating out of, coming from the surface back up towards the top. So it's constantly like moving in like a revolution, basically, where you have the cold, dry air sinking, the warm, moist air rising. So it's constantly wanting to, redevelop itself from its normal state at that point. So that's kind of the structures of thunderstorms, and what the ingredients that we would see with thunderstorms and how they affect the development of thunderstorms. There's always going to be storms that may not make it to the bay, or may not make it to the tidal Potomac, but we certainly will see times where storms will be affected by the bay alone, whether that be the bay breeze or the temperatures along the bay. Do we have a really warm situation in the warmer waters that can certainly amplify these types of storms as well. So just because you may think that the bay alone is not as large as further east towards the open Atlantic, that the implications behind the Chesapeake Bay can certainly affect these types of storms. So a couple examples of lightning data. So I wanted to show I know that I get a lot of questions marine related when it comes to lightning. And what's the best app? What's the best way to look at it? So I'll quickly go over a couple of examples, and these are things that you guys could also see. So it's not something I can just see myself privately. The first one we'll talk about is the GOES GLM data, so the geostationary lightning mapper, which will show the frequency and the amount of lightning strikes across the area. It's got a number of different views and locations that it can look at based off of where these satellites are located at. They can sometimes shift, so they can certainly move these different radar or different satellites. The geostationary ones, obviously, will stay fixated on a certain location and rotate around the Earth with that fixed location. But there are other polar orbiting satellites as well, and then other satellites that can they can actually move and focus on a certain area to look at. Another one we'll look at here is lightning cast. So this is showing. We also have a thing called prob severe lightning cast. So this is basically showing what is the probability of lightning to occur, as well as helping us understand the probability for severe thunderstorms to occur and how severe, how big of an area that we're monitoring at this point. So we can use this dashboard to look at the possibility of lightning as well as the severity of storms as they develop. So we have a way that we can plug this into our forecast database to where we can visualize it using our forecast methods. But you can still look at this on the website. If you type in lightning cast, you can Google this and find the same type of information. It's just we're able to see it in a slightly different way to where we can quickly look at as I'm the warning forecaster or warning operator, I can go and look at this information very quickly and visualize where should I kind of focus my attention on at this point. I can use this as like a proxy to figure out the situations. Other considerations that we use when it comes to forecasting alone and how do we do this, whether it be forecasting or warning, local enhancement. So open waters versus near shore is certainly something that we'll focus on when we're issuing products. So like small craft advisories, I'm typically, a lot of times we'll look at, especially in the Chesapeake, if there are some forecast zones that may not be affected the same way as some of our open waters would be if they're closer to near shore, or they're have a different orientation of them. So that we have to take that into account in terms of those areas. Water temperatures, very, very important. Water temperatures affect winds. They affect if we're seeing a potential for fog. A lot of different things that go into it. Severity of storms can certainly affect that when you have a much warmer water. Model biases. So this is something that I took to very importance when I first started this job, and understanding there when you put a forecaster into a certain location and you drop them in that location, 9 times out of 10 they can do a fairly decent job at forecasting. You can put me in Anchorage, Alaska, and I can do a pretty good job in providing the forecast. But there are local experts within that office that have been around for a long time that understand how the models and how the data is changes locally that you may not be able to understand outside of that office. And so that's why a lot of expertise, local expertise, comes into play, especially in situations like model biases, where most people are not going to see the 3-kilometer NAM and know that it does well with southerly channeling in the Chesapeake Bay. So if I'm having southerly channeling, I'm going to look at the 3-kilometer NAM, and I'm going to kind of use that as like a proxy and starting point for making my forecast a lot of times. And then topographical changes in the Mid-Atlantic. So elevation changes, the Blue Ridge and the Allegheny Front, those higher elevations and along the Appalachians, they certainly affect thunderstorm structures. And we can have like downsloping temperature changes. So a lot of different effects with topographical changes within the Mid-Atlantic. So quickly look at the chat here. Can you please share the link to access?
Yeah.
Yeah. So
yeah, there was a question about the Tempest one, and also a time check. I know it looks like you're near the end because we wanted to leave some other time for other questions. But yeah. Thank you, Austin.
Absolutely, yeah. So in terms of the link to access Tempest One, I could give you the website. I do believe you have to make an account, and it may cost. I'm not 100% sure. We get within the Weather Service, we have our own account, but I can certainly provide the link for it as well. Let's see. Robert Schwartz, how fast does the Coast Guard pick up your alerts to seek safe harbor and broadcast your predictions via VHF. So I would hope that they would have our like NOAA weather radios and a way to pick up that information. So any type of most of the time, any type of emergency response, emergency management, military groups like that, they usually have a way to get our information very quickly. Especially if it's something where it can affect them very quickly, then I'm sure that they have the means to be able to get that information very quickly. Thanks for the questions. So now quickly turn to an infomercial here and talk about two things. So I'll talk about the Marine Weather Ready Nation ambassadors as well as the SKYWARN program. So the first way I'll talk about with the Weather Ready Nation. So the National Weather Service and NOAA have developed this concept of being a weather ready nation. And really what it boils down to is we want to have every organization, every group, every building, office, community to understand what to do in any type of natural disaster, how to prepare for it, how do we, what steps can we take to maybe prevent a natural disaster that's affecting them, such as like flooding. Like, do we need to, shift how we have the structure of our like parking garage or something like that. We want to make sure that the public and the communities are aware of how to become weather ready and prepared and safe from any type of natural disaster that affects them when it comes to weather. So we have, a number of different ways of becoming a Weather Ready Nation ambassador. We have like an application process that we go through, and we speak with these organizations and these groups to figure out, what way can we, what ways do we need to, make improvements or changes to, our current stature to become weather ready. In this pamphlet here, we have, there's 4 reasons, awesome reasons to become a Marine Weather Ready Nation ambassador. Peer influence, so your peers will follow your example during those dangerous weather events. Having that knowledge at your fingertips. So we give out a lot of useful safety information that you may not really think about on a daily basis, and you can get that information as well. A platform to speak. So you're, when you become a Weather Ready Nation ambassador, you're becoming, part of that Weather Ready Nation, and you can use that platform to really, get the point across to the people that you are affecting or that you come across, that they can too become, weather ready and prepared during any type of natural disaster. Organizational pride, definitely a big one. So just knowing that your organization and your group is capable of, being prepared for any type of natural disaster that could affect you. So for, when it comes to marine areas, affected by water spouts, affected by winds, like really strong winds, or just even light winds that could affect, smaller recreational vessel users. So there's certainly a lot of different things that are involved with, becoming a Weather Ready Nation ambassador. But it really boils down to, we just want you to be able to be prepared and be influential with becoming an ambassador by, providing that and showing that example of becoming the ambassador and providing that safety information and preparedness information. So you can visit weather.gov/marine to get more information about that. You can also reach out to me at our office. My goal within the next probably 6 to 7 months would be, I would love to have another 5 new Marine ambassador, Weather Ready Nation ambassadors, whether it be, with CAPCA. It would certainly be, it would be an honor to have you guys as a Marine Weather Ready Nation ambassador. All right, so now we'll switch gears here to SKYWARN. So I'm the SKYWARN program leader here at our office. So what it does is it's a volunteer storm spotter program that's been around since the 70s. There's between 350 to 400,000 spotters in the nation. And so we have meteorologists that will go out in the community. We also do virtually. And we train the public and partners on how to become storm spotters and what it takes to be a storm spotter, and what are the safe ways to record this data. So in terms of the local phenomena that we will report to in terms of spotters: severe thunderstorms, so damage from severe thunderstorms, wind speeds, hail sizes, tornadoes or water spouts, flooding, and is also winter weather, so snow and ice accumulations. So in the average year in the United States, there's over 10,000 severe thunderstorms and 5,000 floods, with more than 1,000 tornadoes. So a lot of weather that I can't go and see, from my office window. Like there's there's not going to be enough eyes in our office to be able to go out and visualize all this happening. So when it comes to SkyWARN, that's a really, really important program within the Weather Service, because you guys are our eyes in the sky. And being a storm spotter is very, very important and a very crucial part of the forecasting and the warning process of a meteorologist in the National Weather Service. Yeah, why we need spotters? They report that observed weather during the potentially severe weather events. We have our mission protecting life and property. We can't do it alone. We need you guys, the local experts, the local visualization of what's occurring. That information you relay to us has the potential to save lives, and has saved lives and property by helping us complete that mission. So we've had, I couldn't tell you how many instances of people reporting tornadoes, large hail, winds, a lot of things that affected us issuing new products or new information, or getting the information out to the public and to our partners and to the broadcast meteorologists. So we use the Storm Spotter program very, very much and a lot to be able to get that information out. So your report it always matters. So never think that when we give out these spotter IDs and you become a spotter, your information and your report is always going to be important to us, whether it be for validation, whether it be for producing another watch, warning, advisory. A lot of great information comes out of being a spotter. This is our website for our SkyWARN page, so weather.gov/LWX/SkyWARN. So these are a couple of our classes that we have coming up. We're going to have a ton more. I'm in the process right now of reaching out to a lot of different counties. So certainly reach out to me or visit our website, and you can certainly get registered for that as well. I think that's all I have.
There was a question here from Ron. Yeah, there's a question from Ron. Is this the program which you hear referenced on the WX station when they reference spotter info?
Yep. So yeah. So when we go, when we issue, there's a product called the Hazardous Weather Outlook that will say requesting spotter activation. This is what we're speaking of. Is the SkyWARN program.
And Alan, you came out on camera. Did you want to?
Yeah, Cheryl, I just wanted to thank you very much. Just to remind everybody that the plan for when we go out to visit the National Weather Service, the Sterling office with Austin, is to train us on becoming SkyWARN, to become part of the SkyWARN program. That program is being conducted specifically on marine weather forecasting, and let us all become SkyWARN. And also, our previous board has already discussed our becoming part of the WeatherWARN Nation. So we're looking forward to working with Austin when we come out to Sterling for that training.
Great. Anybody else have questions? I know it was great that we were able to field them during the program. And Austin, there's so much information. I was taking notes, and I know I'm going to get your presentation anyway, and this is always recorded. So it's really great to have this information, but I just want to open it up if anyone else has any burning question that they get a chance to ask. And did you see the comment there about it's great to see our tax dollars at work in so many weather products?
Yeah, thank you so much, Chris.
That's great. I mean, it's so true. I mean, there's so much there. And I remember, every time I go to the website, it's like, oh my gosh, there's so much. So to have you explain some of it tonight is incredibly helpful.
Yeah, absolutely. When it comes to, there's a strong push towards the social science aspect of meteorology and being able to provide very concise, consistent information that anybody can read and visualize. And that's, it's become very important because we want the public to be able to, visualize that information and understand, what we mean by the forecast and what's going into it.
Well, thank you so very much. And thanks for also providing everyone your contact information. The joke in my house and my family is that my husband is a very frustrated, like, why weren't you a meteorologist? Because he just really geeks out on this stuff. So I'm going to share a lot of what you just shared with him, and look forward to him hopefully volunteering to be, one of those spotters. So we'll see about that. But thank you, Austin. And as Alan said, we're really looking forward to the tour in April and really appreciate also your leadership with the MUC meetings as well. So we've, CAPCA's appreciated our involvement with you, throughout all this. So thank you so very much. Anybody else have anything? All right. We've got a couple more little thank yous in the chat coming in. All right. Well, with that, we'll conclude our meeting for this evening. And again, our sincerest thanks, Austin.
Of course. Have a great day.